Good morning, gentlemen, it's Monday. Recently I was playing The Outer Worlds and I looked out the window of my spaceship and I saw something incredible. Wow. This is kind of what it would look like if Jupiter was as close as it is on some of those planet charts. But this reminded me of a talk I listened to a while ago called Juno and the New Jupiter, What We've Learned So Far from NASA. And basically, just to summarize the whole thing, it's really freaking cool. All the amazing information I'm about to share with you comes directly from this talk. If anything I say piques your interest, please go listen to the whole thing. It's only an hour and a half long and it's well worth your time. So Juno is a high-tech satellite with tons of instruments on it to collect different information from Jupiter and send it back to Earth. Juno launched all the way back in August 5th, 2011, and has been orbiting Jupiter since July 4th, 2016. Yes, that's right, it took almost 5 years for Juno to reach Jupiter. So Juno's in a 53-day orbit around Jupiter. That means every 53 days it gets close enough to the planet that it can record a huge burst of data and send it back to Earth for analysis. So what's the purpose of Juno? What did NASA have in mind when they sent it? Well, they had a few things in mind. First of all, they wanted to understand the origin of Jupiter and how solar systems form. 99.5% of the mass in our universe is the sun, which was the first celestial body to form. And out of that 0.5% that's left, roughly 2/3 of that is Jupiter. Jupiter was the second to form, and everything else in our solar system from the Earth to asteroids came after that, and is comprised of that 1/3 of 0.5% that's left from the sun and Jupiter. So basically, Jupiter formed from the leftovers of the sun, and everything else formed from the leftovers of Jupiter. They also needed to know more about the core of Jupiter. So Jupiter is a gas giant. It's made up mostly of hydrogen and helium. Interestingly enough, it does have a solid-ish core. More on that later, but they needed to know how big it is and what exactly it's made up of. The current theory of how Jupiter was formed is that over time there were a bunch of asteroid-sized pieces of ice that would collide and stick to each other, until eventually over a massive length of time there was enough mass to keep in the hydrogen and helium to create a gas giant. They also wanted to know about the atmosphere. So all we can see from the surface of Jupiter is the jet stream belts that go across the planet. We can't see below those. We had basically no idea what was happening below those jet streams, which is a big deal because most of the planet is atmosphere. Take for example the Great Red Spot. A storm bigger than the entire Earth. Jupiter has a lot of strange weather and it needs to be understood. And then there's the magnetosphere. So Juno has a very specific flight path that it needs to follow. Juno flies around the poles and crosses all the magnetic field lines, because out further away from the planet there are a ton of high-energy particles and radio waves that would fry all of Juno's electronics. So Juno's orbit allows it to avoid most of those high-energy particles and radio waves while still obtaining a large amount of data about the magnetic field. So this is all great, but how do we get information about what's actually underneath the top layer of clouds? You might think it would be easiest just to drop something into Jupiter that we could record data with. However, the problem with that is Jupiter is so big and has such an immense amount of pressure that anything we could build would be destroyed. So we need to find a different way to find out what's underneath the top layer of clouds on Jupiter, and that's where Juno's different instruments come in. So Juno has a bunch of different instruments that can penetrate the atmosphere of Jupiter, such as microwaves and radio waves, and then they can be received back in various ways. Also, the gravity and electronic field of Jupiter can help us understand a lot more about what's underneath. Jupiter's electric field comes from its core, which is made up of metallic liquid hydrogen. Yes, that's right, metallic liquid hydrogen. This stuff is really freaking cool, but I'm not going to get into it here because they do such a good job of explaining it in the talk, and I really think you should go watch that if you're interested. But anyway, understanding the magnetic field can give us a much better understanding of what actually lies beneath the surface. So what have we actually learned since Juno launched? Well, there's a few things. Basically, everything we thought about Jupiter was completely wrong. It had to be thrown out and corrected because of the data that we got. But here's just a few of the more interesting discoveries. The poles look completely different than the sides of Jupiter. All these crater-looking things are storms, most of which are bigger than the entire United States. So not only are there far more storms at the poles, but there's also no jet streams like there are on the sides of Jupiter. It's also a lot more blue at the poles for some reason. Now, the blue in this picture is exaggerated, but it's still pretty darn blue. And they don't know why yet. They think it has something to do with the exact mixture of gases, but they don't know for sure. Circumpolar cyclones. Okay, these red infrared images are really freaking cool. In the South Pole, there are 5 cyclones orbiting another cyclone, and in the North Pole, there are 8 cyclones orbiting another cyclone. And for over 2 years that they watched these cyclones, they drifted around a bit, but they didn't really change at all. And even more interestingly than that, the cyclones are all flowing the same way. This is a big deal. Imagine the cyclones are a bunch of gears all flowing the same way. It shouldn't work like that, but it does. They should end up swallowing each other, switching directions, or changing somehow, but they don't. They're constant. So there must be something very powerful causing this strange weather. So we can only see a few hundred kilometers below the clouds, which are mostly made up of pneumonia and water. So the thought was that after we saw past the surface layer of Jupiter, we'd be able to see past the water and pneumonia and see all the mixed gases underneath. But even 350 kilometers down, that's about 217 in freedom units, there's still pneumonia that's not mixed with the other gases. And we don't know how far into the planet this goes because we can't see that far. As far down we can see is just water and pneumonia. So in the grand scope of Jupiter, it's really not that far into the planet because Jupiter is so huge, but it still presents a huge problem to actually seeing past just the surface of Jupiter. So speaking of how far down we can see, you know the Great Red Spot, the storm that's bigger than the entire Earth? That also goes further down than we can see. It was thought to be just a surface storm, but no, it's much bigger than that. Also, near the surface, the Great Red Spot's pretty cool, but as you go further down about 150 kilometers, about 93 in freedom units, it gets very hot in the middle. Something about the Great Red Spot is changing as it goes down. Belts and zones. So we also learned that the belts and zones go about 3,000 kilometers deep into the planet, about 1,864 in freedom units. And under that, the planet rotates like a solid body, even though it isn't. Now, it's theorized that the magnetic field could be generated around 3,000 kilometers deep, again about 1,864 in freedom unit, and that might be the reason that the belts and zones only go this deep. So there's a lot more that I could say about Jupiter, and in the NASA talk, they go into a lot more detail and talk about even more than I have, but I'm a busy boy, I don't have all day to spend on this, so I have to move on. I'll leave some links down below to both the NASA talk and some other things that are interesting about Jupiter. And gentlemen, I'll see y'all soon.